This morning, when your alarm went off, the sky outside your window was already turning pale gray. You didn't think about why. You just accepted it, the way you accept gravity, the way you accept that your coffee gets cold if you leave it too long on the counter. But underneath that ordinary sunrise is one of the most violent processes physics has ever allowed to happen quietly. Earth is spinning at over 1,000 miles an hour at the equator right now, and you don't feel a thing. Now imagine it just stopped, not slowed down gradually over centuries, stopped in the space of a single day. The real answer to what happens next is far stranger and far more destructive than a longer sunset. Your body is not the only thing that would notice. Everything on the surface of this planet is currently moving at the same blistering speed you are. The air above you, the ocean beneath the nearest coastline, the clouds drifting overhead. All of it is being carried along by the planet's rotation, and all of it is moving in sync, which is the only reason it feels like nothing is moving at all. If Earth's rotation suddenly halted, the ground beneath your feet would stop, but the atmosphere wouldn't. Wind doesn't stop just because the surface below it does. Physics has a word for this, and it doesn't negotiate. It's called inertia. The atmosphere, still carrying the momentum of that 1,000-mile-an-hour spin, would keep moving even as the ground beneath it froze in place. What would that look like? Winds stronger than anything a hurricane has ever produced, not a storm passing through. A permanent planet-wide gale scraping across every continent, fast enough to flatten forests, strip roofs from buildings, and erase coastlines within hours. The oceans would do something similar but slower and heavier. Water piled up at the equator by millennia of spin would surge outward and sideways, flooding coastlines that have never seen a wave larger than a swimmer could handle. Tsunamis without an earthquake, just inertia, finally collecting on a debt no one knew was owed. Why would the water be piled up at all? Because a spinning planet isn't just spinning, it's holding a shape. Earth bulges slightly at the equator, a direct result of that same rotational force, the same reason pizza dough spreads outward and thins in the middle when it's tossed and spun in the air. Stop the spin, and that shape has nowhere to go but back toward a perfect sphere, dragging every ocean and coastline along with it as the planet quietly reshapes itself underneath civilization. And there's a second, quieter horror waiting on the far side of the wind and the water. If the stop lasted, one hemisphere would face the sun without relief. No sunset, no cooling. Temperatures on that side would climb for hours on end, turning entire regions into slow ovens. The other side would tilt permanently into darkness, losing warmth with nothing to replace it. You live on a planet fine-tuned by rotation to spread heat evenly, like a chicken turning over a fire. Stop the turning, and one side burns while the other freezes, both suffering from the same missing motion. And this is only the visible damage. The deeper cost is invisible, slower to arrive, and far more dangerous. Earth's magnetic field isn't decoration. It's generated deep inside the planet by the churning of molten iron in the outer core, a process driven in part by the planet's rotation. Scientists call this the geodynamo. Slow or stop that rotation, even briefly, and the magnetic field that quietly deflects solar radiation every second of every day of your life would begin to falter. That field is the only reason the sun's radiation doesn't strip away the atmosphere the way it did on Mars billions of years ago. Without it, even a short-term weakening leaves the planet more exposed, more vulnerable to the kind of radiation current life was never built to survive. There's a third casualty most people never think about at all: weather itself. Hurricanes, trade winds, the great ocean currents that keep entire coastlines habitable, all of them are shaped by the Coriolis effect, the subtle sideways push caused by Earth's rotation. A hurricane doesn't spin because the ocean is angry. It spins because the same rotating planet that carries you also curves the path of rising air, twisting it into the recognizable shape you see from satellites. No spin, no Coriolis effect. The predictable patterns that have guided sailors, farmers, and migrating animals for thousands of years would simply cease to exist. replaced by something the planet has never experienced in the history of complex life. Even the birds would notice before you did. Migratory species navigate partly using Earth's magnetic field and partly using cues tied to the planet's rhythm of light and dark. Disrupt the spin, and you don't just disrupt human commuters checking a sunrise. You disrupt a signal that animals have followed for longer than humans have existed at all. Here's the part that should really unsettle you. This isn't just a thought experiment floating in pure fantasy. Earth's rotation actually does change all the time, not by stopping, by fractions of a second, and scientists have learned to measure it with startling precision. Geophysicist Richard Gross at NASA's Jet Propulsion Laboratory studies exactly this after the 2004 Sumatra earthquake and again after the 2011 Tohoku earthquake in Japan. Gross calculated that the redistribution of the planet's mass, rock shifting suddenly during the quake, actually measurably changed how fast Earth spins. Each event shortened the length of a day by a few millionths of a second. A few millionths of a second doesn't sound like much, but it proves something important. Earth's spin isn't fixed, it's a balance, constantly being nudged by forces most people never think about, and that balance is more fragile than the calm rhythm of your sunrise makes it feel. The slowing goes back much further than any single earthquake, too. Historian and physicist F. Richard Stephenson has spent decades studying something that sounds almost absurd: ancient records of solar eclipses, some over 2,000 years old, carved into Babylonian clay tablets and described in Chinese court records. By comparing where those eclipses should have been visible against where ancient witnesses actually recorded seeing them, Stephenson and his collaborators calculated that Earth's rotation has been gradually slowing for millennia, dragged down by the tidal pull of the moon. Millions of years ago, a day on Earth lasted closer to 18 hours. It's getting longer, slowly, silently. One of the most stable things in your life, the length of a single day, has never actually been stable at all. So what if it stopped completely for one day and then started again? The restart might be worse than the stop itself. Every particle of atmosphere and ocean that had spent a full day dragging against a frozen surface would suddenly be forced to accelerate back to rotational speed, all at once, everywhere on the planet simultaneously. It's the difference between a car braking hard and that same car being thrown back into motion by something far more violent than any engine. The planet wouldn't just experience one catastrophic day, it would experience two, bookending each other with nothing but chaos in between. There would be no cleanup crew, no recovery window, no quiet stretch to rebuild before the second wave of destruction arrived. Just a planet lurching back into a rhythm it was never supposed to lose in the first place. There's an older idea that circles all of this, one from a Serbian scientist named Milutin Milankovitch, who spent his career studying how subtle changes in Earth's rotation and orbit, not sudden stops but slow wobbles and tilts unfolding over tens of thousands of years, have repeatedly triggered ice ages throughout the planet's deep history. Milankovitch never imagined a planet stopping outright. He didn't need to. He proved that even tiny, gradual shifts in how Earth spins and tilts are enough to reshape climate, ecosystems, and the fate of entire species over time, without a single dramatic moment anyone could point to. Which raises the real question underneath the thought experiment. Why does any of this matter to you specifically on an ordinary day when nothing is stopped and nothing seems to be at stake? Because your body already runs on Earth's rotation, whether you've ever noticed it or not. Every cell in you carries a roughly 24-hour internal clock tuned by millions of years of evolution to a spinning planet with a rising and setting sun. That's why jet lag feels like a kind of quiet illness that follows you across time zones. Your body isn't confused about the clock on the wall. It's confused about rotation, about light hitting your eyes at the wrong point in a cycle etched into you long before you were born, inherited from ancestors who never once questioned why the sun came up. You have never lived a single day that wasn't built on top of this spin, not one. The rhythm you call morning, the tiredness you call night, the hunger that arrives at roughly the same hour without being asked, All of it is a quiet inheritance from a planet that has never, in the entire span of human history, stopped turning underneath you. Think about the last time you scrolled through your phone in bed at midnight, the screen glowing against your face. You were, in a small way, arguing with the planet. Artificial light lets you pretend the rotation doesn't apply to you, that you can simply choose your own sunrise. Shift workers know how costly that argument can be. Studies on people who work through the night for years show elevated rates of sleep disorders, metabolic problems, and long-term health risks, all traced back to a body still trying to follow a spin it can no longer see. You can dim the sun with a curtain, you cannot dim the rotation it depends on. Maybe that's the strangest part of the whole thought experiment. Not the hurricane-force winds, not the flooding coastlines, not the magnetic field flickering under a wave of solar radiation. It's that you are, at this exact moment, a passenger on something moving over 1,000 miles an hour, and it has never once felt like movement at all. Tonight, when your alarm goes off tomorrow and the sky outside your window turns pale gray again, you won't think about why. You'll just accept it, the way you always have. But now you know what that quiet, ordinary sunrise is actually made of. A planet spinning fast enough to flatten cities if it ever stopped, slowing by fractions of a second with every earthquake it survives, and never once asking your permission to carry you along for the ride.